Now we'll talk about inverse variation problems. If x and y are related by an equation of the form y equals k over x to the n, where k is a non-zero constant, and we say x or y varies inversely with the nth power of x in inversely proportional relationships or inverse variations, there is a constant multiple k, as we had before, but this time it's k equals x to the n times y. Now, one way to think about this is, we have distance equals rate times time. If I'm pencil, d equals rt. I used it before where I said rate was held constant. But what if I said time was constant? The time you're traveling is constant. So if the time is, distance, let's say distance is constant. If your distance is constant and your rate goes up, the time goes down. But if your distance is constant, like you're driving from Reno to San Francisco, fixed distance to travel. And if you're going to travel at 60 miles an hour, you have a certain time. But if you travel at 80 miles an hour, which is against the law, you'd have a lower time, except maybe not if you get pulled over. If you traveled at 50 miles an hour, you'd have a bigger time, which might, so just that's the idea behind an inverse relationship. As one goes up, the other goes down. So like if you hold distance constant, rate goes up, time goes down. If rate goes down, time goes up. Okay, let's look at example 2. It says a tourist plans to drive 100 miles. Find a formula for their trip. It will take as a function of the speed of the tourist that the tourist drives. So again, I said distance equals rate times time from earlier. And our distance in this case is 100. So 100 is equal to, so we want the formula to be the time of the trip based on speed. So rate times time. We want to solve for time, so we divide by rate. So time equals 100 divided by r. So the time it takes is going to be 100 over the rate the person goes. So how to solve for an unknown in an inverse variation problem. Identify the input x and the output y values. Determine the constant of variation. You may need to multiply y by the specified power of x to determine the constant of variation. Use the constant of variation to write an equation for the relationship. Then substitute known values into the equation to find the unknowns. So write a quantity y varies inversely as the cube of x, so k over x cubed. So as soon as I read inversely, I know it's going to be k over something. If y is 25, so 25 is k over 2 cubed. Find y when x is 6. So very similar to the last one, but this one it's inverse instead of direct. So we have 25 is k over 8. Multiply both sides by 8. K equals 200. So y is 200 over x cubed. And we want to look at this when x is going to be equal to 6. So 200 over 6 cubed is 200 over 216. I'm trying to think what would reduce out of that. I think we can divide an 8 out of both of those. Didn't we do that earlier? And on top we'd have a 25, and on bottom we'd have a 27. And I think that's it for that problem. And I think that's it for this video, because the next video is going to be talking about joint variation. So, okay, see you in the next video.